Hello everyone, I hope you all are doing well. In this video I will discuss about working principle of DC machine. Okay, for first type of DC machine we will discuss about DC generator, direct current generator. So we discuss how the generator generate electricity. Okay, generator, we know that for generator from mechanical energy convert to electrical energy. Okay, from mechanical convert to electrical energy. So the generation of energy is based on this equation, motional EMF equation. Motional EMF is equal to B L V sine theta. Okay, B is the magnetic field, L is conductor length, V is velocity of the conductor. Theta is angle between velocity of conductor and theta is angle between B and I, B and V, velocity of the conductor and magnetic field, that theta. Okay, first one of the important part in DC generator is commutator. Okay, this part is this two part is static part or stator. Okay, in this case we use permanent magnet. Okay, stator, and this part is rotating part. Okay, rotating part. Okay, so this part we rotate. Coil and commutator. This one we call commutator. We can see that commutator, they are half commutator. Wait, I need to delete. Okay. Okay, we have commutator, half. Okay, half commutator. Sometimes they call slip rings. Half slip ring, half and half. So there are two half side and two half slip ring. For this case, we use just one coil only. One coil, so there will be half slip ring, one for one coil. If we use two coil, so there will be two pair of slip ring. So each slip ring connect to coil. Okay, connect to a coil. Okay, also we can see that this is we call brush here. We call brush. Okay, you can see that this brush is connect between rotating part. So this coil and commutator will rotate. We rotate together. Coil and commutator will rotate together. Then so this commutator rotate. So the function of brush is to connect between rotating part and external circuit. Okay, this one is we call external circuit. Okay, external circuit. So the brush is connect rotating part and external circuit. External circuit is fixed. That one not rotating, static. So this carbon brush, like a block, it will always press against the commutator. it must press to make sure it contact, because commutator is rotating, commutator is rotate, so brush must be press that rotating part, okay, to make sure that rotating part is connect together with external circuit. So rotating part is they use the rotating part is to generate the electricity. Then the electricity will be transferred to the circuit using brush. Okay, that's why the brush must press. This brush must press the contactor. Okay. So first we study how the electricity is generated by generator. Okay. First figure. So look at this first figure. Based on Faraday's law say that when the conductor cut the magnetic fields, what happened? Okay, when the conductor cut the magnetic field, there will be induced EMF at the conductor. So when the conductor is closed circuit, so there will be flow of induced current. Okay, in this case, this is conductor, and this is not conductor. So conductor connect to slip ring, connect to commutator called slip ring. So when conductor harvest the energy, we call generate the energy, induce the current. So the current will flow through the contactor, then go to brush, and then go to external circuit. Okay. So, okay, we divide into 5 figure. Figure number 1, figure number 2, figure number 3, 1, 2, 3, figure number 4, and figure number 5 into 5 stages. Okay. Okay. At figure number 1. Okay, we can see that this conductor. Okay, let's so to harvest to generate the energy to cut the field. Okay, we know that between north and south pole there will be magnetic field. Okay, we have conductor here. Okay, so first we need to move this conductor. So let's say we give external mechanical force. Okay, here. Let's say we have handle here. We used to rotate this handle. When you rotate this handle, this conductor will rotate or will move here. This conductor move there. So it rotate. So what happened when this conductor rotate? Okay, we know that based on Faraday's law, this the moving conductor will cut the flux. Okay, will cut the blue color, green color. When green color move, it will cut the flux. Will cut blue color. Okay, it will cut the flux. Green color. This conductor will cut flux, so there will be induced EMF there. So we call induced current in the conductor itself. Okay, so for the first figure, starting here, okay, magnetic field is from here, from B to S, from north to south, B magnetic field. So the conductor move from here to here. Now we want to rotate. So from here to here, Okay, we can see that the moving of conductor and B is in parallel. So parallel, or the angle is 0. So when angle is 0, what happens? There is no EMF. When angle is 0. Okay. Conductor and parallel, conductor and B magnetic field, same direction, parallel position. So that means there is no induced voltage there. Rate of cutting B is 0. Okay, the same direction, so there is no cutting magnetic field. So there is no generated voltage. That's why 0 here. Our output will be 0. Induced voltage 0. Okay, that one is during at this position. Then when it rotate the conductor moving here and here. Okay, we call that one is 90 degree. 90 degree. The position of conductor now is 90 degree. So we know that at this point perpendicular, that means the conductor is perpendicular. Now conductor perpendicular with B. So that one for perpendicular, the rate of cutting B will be maximum. The rate of cutting magnetic field is maximum at this point. So if we replace this one with 90 degree, so sine 90 go to 1. So at this part, the voltage increase to maximum. Okay, this part is 0, so now it will increase to maximum due to the movement of that one to the maximum. Then for figure number 3, so it will rotate again, continuing rotate. Now it become 180 degree. Okay, 180 degree. Same as figure number 1, 110 degree. So the conductor now, the moving of conductor parallel with magnetic field here. So parallel, that means it will decrease to 0. From maximum, from peak, decrease to 0. Okay, from peak, decrease to 0. Okay. Then it continue rotate. So from 0, it will increase to maximum 90 degree. This conductor become perpendicular with the B. So perpendicular with B, you repeat to maximum. Okay. Why the waveform still positive waveform? Okay, based on, we can see that this commutator. Okay, first let's say this commutator. Now this commutator rotate here. So current will flow. Okay, current will flow that direction. Then you can see that the commutator will change to here. And then this connector change to here, commutator. So the current still this direction, same direction. That's why the waveform is still like this. Okay, means that the commutator is used to maintain the correct polarity. So the polarity will be always same. So commutator maintain the polarity. Okay. Okay, the final in the final figure, figure number 5, then the again same as figure 3, from perpendicular, from the this connector perpendicular moving to parallel. So parallel, the movement V is parallel. V is parallel with B. Velocity of conductor is parallel with B. So that means 0 degree here. Okay, perpendicular. Sorry, parallel. This one is parallel. This one is perpendicular. 90 degrees perpendicular. Parallel is 0 degree. Parallel. 90 degrees perpendicular. Okay. 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 From this equation, we can say that the amount of EMF. Sorry, I need to delete. Okay. The amount of EMF is depend on B, magnetic field. So it depends on magnetic field strength. Okay, in our case we use permanent magnet. Okay, in reality they will use winding field, electric field winding. So that strength of winding will uh, will determine the amount of generated EMF. So if we want more EMF generated, so we have high strength of magnetic field. It also depends on L. L is conductor length. Okay. The amount of EMF also depend on velocity, speed of rotation, speed of rotation of conductor rotation. So, okay, it depends on conductor length too, and also it depends on amount of conductor, amount of length, amount of conductor. Let's say, let's say, let's say, okay, this one we put another conductor here. So there's 2 conductor. So split ring we have 4 slip ring. So 2 conductor. First conductor is the existing one. So in this case we have 2 conductor. So 2 coil. 2 coil, that means 4 conductor. So it can generate. Okay, the displacement is 90 degree. You can see that 90 degree. So that means the next they generate from okay, this red color. Okay, the waveform of red color generated by red coil. Now I want to change to green coil. So green coil generate green color. Okay, the displacement is 90 degree due to displacement of this conductor 90 degree. So what happened? We can see that the total generated EMF will be like this. Combination of both. Okay, like this. So the total will be, okay. This one is we call this one we call rectified DC voltage. Okay, this is voltage. So just imagine if we put more coil, so there will be many waveform. So the total waveform will be just straight line. So this is DC voltage or the output. Okay, that's why it depends on conductor length too. Okay, I think that's all. Thank you very much. Bye bye.